Hi everyone, so in this video series we're going to look at creating multiplayer code and multiplayer games. This tutorial series will assume that you're using the Blender game engine, although it doesn't have to it's not obligatory, and most of the start of these videos will not require you to do so. It's only the later part of the series. We're going to have very short videos describing different parts of the system, and you can follow the series through to see how they all link together. So an overview. In this network system, data can only be sent to or from the server if you use Python objects which inherit from the base class replicable. So let's have a go at creating that. We'll need to import the network library. So import network. I'm going to create ourselves a class, printer, and it's going to inherit from network.replicable. Okay. Now, there are two ways of sending data. There's RPC calls and attributes, and for the purpose of this particular video we're going to look at network attributes. So to define a network attribute on the class, which is where they are defined, first type its name, which in this case will be my_name, and we're going to set it to be a network.attribute instance, and this attribute must be uppercase. The variables are it's network.uppercase attribute, not lowercase, and the first argument is its initial value. You can either give it as an instance of a value, let's say 100, which is an instance of an integer, or 10.0, which is an instance of a float, or you can give it as a string, let's say hello, or you can set it to none by just telling it the type of the variable. So in this case we're going to set type of equals str, meaning that the current value of my name will be none, but we'll know that it's a string type. Now, in order to send these over the network, we also need to define when we send network attributes. So to do that, we create a function. It's a generator function called conditions. It accepts three arguments: is owner, is initial, and is complain, although the order is different as if you read off the screen. Is owner refers to if the client we're sending to owns this network object, which we'll come on to later. Is complain refers to if the network attribute has been explicitly told to complain when it's changed, which I will refer to later. And is initial tells you if it's the first time we've ever sent data to this client. So to send an attribute, we simply yield its name. So if I yield my_name, we would send the attribute my_name over the network when it changes. To compute if an attribute has changed, we run a hash function on it, which can be quite expensive. If you have three different attributes, let's say my_name and my_name2, and then my_name3, you'd run a check on every single one of these attributes to see if it's changed. Often you'll change a batch of attributes in one go, or they'll change very infrequently, meaning it's a waste of processing power to check them every single time we want to send data. Instead, let's tell the system when they've changed rather than it checking. To do that, they need to complain. The way the complain system works is that if any of these attributes is set to complain, when any one of them is changed, this variable argument will become true. To make it complain, we simply give it an argument in the attribute complain equals true. And if we did this to all of them, then when any one of them is set, is complain will become true. So now if I add the if condition, we'll only do the hash function on these attributes if any one of them is changed. This is less useful for frequently changing attributes like physics, but it is useful for this. We can also receive a callback over the network. Well, not so much over the network. The client can be notified when an attribute has changed by the network, and to do that we define ourselves a callback, define on notify, and that accepts a name argument, which is the name of the network attribute, and then we can say print name has changed. But in order to have this function called by one of these attributes when they're changed, we need to give them an argument, notify equals true. And that will make them notify. In this example, whenever my name is changed over the network, the client will print my name has changed. It should be noted that the base class replicable has also some attributes defined on it, and it already has a default on notify and default conditions. So it is always good practice to yield from the superclass conditions and provide the arguments to avoid breaking. That's all for this video. See you in the next one.